Hello and welcome to my lab. I have a giant 25 kilogram spool of filament here for the printer because I don't like running out of filament, and this is probably going to last me about 2 or 3 years. That's great, but the printer isn't going to be able to eat this on its own. It's going to need some help. So I've designed a spool handler that'll be able to hold the whole thing and actually spin it on behalf of the 3D printer so that we can just keep this thing fed and not affect the 3D print. So let's go take a look at the design there. Here it is, and it looks like there's a lot going on here, but it's pretty straightforward. So let's look at the spool first. It's on a half-inch shaft here, and that is just held in place with a couple of 3D printed nylon spacers here. They just keep the thing centered on the shaft and provide the grip to spin the whole spool. The shaft comes out right here, and I'm just going to use a pulley that goes straight to a motor, a DC gear motor, and that will spin the entire shaft and spin the spool. This will give us the slack that the 3D printer can eat up. This whole assembly is going to go beside the 3D printer, and the filament is going to go up from the bottom, in through this eyelet, and then straight down into the printer. The arm that connects to the eyelet here is actually going to swing up and down. I'm going to put some weight on the opposite end that will make gravity pull it upwards. As the 3D printer eats the filament, it's going to pull down on that eyelet. Then we have a prox here that senses if it's all the way down, and a prox here that senses if it's all the way up. Then all we have to do is write a little bit of a latch that will spin the spool in order to build this buffer back up. And this little arm will go back up to the top. We'll read it off of this prox here, and we'll know that the 3D printer will have a good amount of filament in the buffer. As usual, I'm going to just be 3D printing an enclosure for the electronics. So we have a power supply, the motor driver, which is going to be a simple voltage PWM driver, very, very straightforward for the microcontroller to control. The microcontroller is just going to go into this slot, which I just copied from the last project that we did. And it's really just that simple. We've got power coming in, we've got the two proxes coming in, and then we have the motor power coming out there. All the components here are relatively cheap, and we're working on building a forum where we can post where we got all the little bits and bobs, so that maybe you can take some of our ideas and make your own machines with it. For instance, these pillow blocks here are only $15, and they seem to work great, so that's a really good deal on Amazon, and we'll hopefully just upload a link to that in a forum post in the future. So at this point, we just need to cut all the individual pieces of square tubing and start to fabricate the whole frame. We don't have a bandsaw or anything like that yet, so we have to mark and cut each side individually with the grinder in order to get a straight cut. Once we have all the pieces of the frame cut and cleaned up on the grinding wheel, we can move on to the part of the frame that's going to hold the swing arm. First, I drill the hole that will clear the shaft of the swing arm. And then I'll attach the pillow bearings that will hold the swing arm. And now I've created a fidget spinner. Anyway, let's move on to the frame. I'm going to measure the first side really carefully, tack that together, and then I'm going to lay the second side on top of it. I quickly cleaned up the welds with a grinder, and I'll go over it again with a flap disc before we paint it. Now to create the mounts for the pillow blocks. I'm going to use sections of this all thread welded to the frame to accomplish this. Perfect fit. Now let's move on to the swing arm. This hole is going to be for the shaft of the swing arm. It's just going to be welded in place. And this larger hole is going to be for the eyelet that's going to hold the filament. Drilling larger holes with this drill press gets a bit sketchy sometimes. I'll give it a quick assembly to make sure everything fits just right. Then I'll cut and clean this shaft so that we can weld it in place. Here I'm going to place my tack such that the distortion that comes with welding is actually going to pull the shaft into alignment. And it worked surprisingly well. Okay, let's test the fit to see if everything worked out. Here I was prototyping a couple of different ideas for the counterbalance. I ended up going with this nice block of metal here. With that, I'll go ahead and cut these pieces that I'm going to need for the prox mounts. Here is everything all shined up. Now let's start putting stuff together. Once again, drilling a hole that's any larger than tiny gets a bit dicey. I really need to get better equipment. Now that those are done, let's get the counterweight welded in place. Oh yes, that feels real good. Now let's get these end stops in place. A tack here, a few smacks there, and we've got it. Same thing on the other one, and we're good to go. Lastly, let's just get that motor mount in place, and then we can paint it. Here you can see I've cleaned it up and tapped the necessary holes. I've already measured where I want it to go, so I just need to weld it in place now. Now let's see if everything lines up. Nailed it. And here's the finished frame. I painted it matte black, and I really like how it turned out. I've also already printed and painted the electronics enclosure. I don't know how well you can see it, but this is a silver pearl in a blue paint. And then I lacquered over top of it. So that should be really shiny at some point, but I have to let the lacquer cure for a couple of weeks before I can buff it. In fact, I've already accidentally put some fingerprints in it. But that's going to look really nice. So the only thing left to do is to assemble everything and wire it up. Here are those proxies I've been talking about. They just get tightened into place using 2 nuts. The electronics enclosure just hugs right onto the frame here. Now let's take care of the electronics. This is the power supply. It's going to give us 5 volts for the microcontroller and 12 volts for everything else. I'll be using these Wago lever nuts for everything. They're very handy. And here's the motor driver. We're just going to control it using a direction signal and a pulse width modulation signal. I've already soldered everything onto the microcontroller, and now it just needs to be wired up. This will be the 5 volts, and this is the 12 volts. Here's common, and once I put everything in place, it should just work. Now I'll cut the prox cables to size. And wire them in. And the signal will go right into the microcontroller. Same thing for the other one, and now we'll wire up the motor. The wires will just go right into the A and B terminals on the driver back there. And once that's done, we can just close it up and give it a try. Perfect. Now let's just get the spool on there. done, and it works! Just like that. So this will allow me to print without any kind of concern for how much filament I have left, and I can get these giant spools for $15 a kilogram, so we're in business. So I'll just leave you with some shots of it working, and we'll see you next time.
I want me some of that filament, boy. And I'm gonna get me some of that filament, boy!